Good evening to all. Today I am going to discuss about Boolean laws. This topic will cover under digital logic circuits in first unit. Before going to this topic, we will discuss about the logic gates. Logic gates is mainly used to store the binary values. In digital system, we are using either 0 or 1. In digital system, 0 means a false value and 1 is a true value. But in analog, we will take more values. There are so many advantages in digital circuits. In digital signals, it is easier to communicate with computers using formal logic. Then, Boolean function. Boolean function is mainly used to mapping from Boolean variables to a Boolean value. The next one, truth table. The truth table represents a relationship between a Boolean function and its binary variables. It enumerates all possible combinations of arguments and the corresponding function values. Boolean laws is mainly used to reduce the following Boolean expression, and it is mainly used to design a digital logic circuits. Boolean laws, it is also used to reduce the Boolean function, and it is mainly used in came-up simplification. Next one, Boolean function and a logic diagram. Boolean algebra. Boolean algebra mainly deals with binary variables and logic operations operating on those variables. In each and every circuit, we will draw the logic diagram. In digital logic circuit, logic diagram is one of the important point. In each and every problems and every topic, we will have logic diagram. The logic diagram composed of graphic symbols of logic gates, a simple circuit sketch that represents inputs and outputs of Boolean functions. In previous video, we will discuss about the basic logic gates. The universal gates are NAND gate and NOR gate. NAND gate and NOR gate are mainly used to construct all logic gates. So these logic gates we will call universal gates. Now I am going to Boolean laws. First law, x plus 0 is equal to x. This is the first law. Now x is a variable and 0 is a value. Now I am giving x equal to either 0 or 1, because in digital system we will use either 0 or 1 only we will use. So in first equation, x plus 0 is equal to x. I will give the proof. Initially I am giving x equal to 0. 0 plus 0 equal to 0 only. So same x value you can get. Suppose if I am giving x equal to 1, 1 plus 0, 1 plus 0 is equal to 1. So left hand side x equal to 1 and also right hand side x equal to 1. So left hand side and right hand side also equal. So we can get a proof. So therefore x plus 0 is equal to 0. Then next one, AND operation. X dot 0 is equal to 0. In x variable, I am giving either 0 or 1. Initially, I am giving 0. 0 dot 0 is equal to 0 and 1 dot 0 is equal to 0. So input value 0 or 1, we can get output value is only 0 only. Then third law, x plus 1 is equal to 1. In this x value, I am giving either 0 or 1. Initially, I am giving 0. 0 plus 1, you can get 1. Suppose if I am giving x equal to 1, 1 plus 1 is equal to 1. So x value either 0 or 1 means you can get the final answer is 1 only. So therefore x plus 1 is equal to 1. Then fourth law, x dot 1 is equal to 1. In this particular variable, I am giving either 0 or 1. 0 dot 1 is equal to 1 and 1 dot 1 is equal to 1. Then fifth law, x plus x equal to x. Here I am giving 0. 0 plus 0, 0. So therefore x value same left hand side and right hand side also same value. In this particular place, I am giving x equal to 1. 1 plus 1, you can get answer is a 1. So therefore x equal to x plus x means your answer will be x only. Then sixth law, x dot x equal to x. Here I am giving x equal to 0. 0 dot 0, 0. Suppose if I am giving x equal to 1, 1 dot 1 is equal to 1. So therefore x dot x equal to 0 only. Then seventh law, x plus x bar is equal to x. Here I am giving x equal to 0. Seventh law, input variable initially I am giving x equal to 0 plus x bar. X bar means inverse. What is a 0 inverse? 0 inverse equal to 1. 0 plus 1 is equal to 1 only. Suppose if I am giving 1, 1 plus 0, x bar value here 0. So therefore 1 plus 0 is equal to 1. So therefore x plus x bar is equal to x. Then x dot x bar. Here I am giving x equal to 0, then x bar is equal to 1. 0 dot 1 is equal to 0. If I am giving x equal to 1, 1 dot 0 is equal to 0. This is a Boolean laws. Then next one, commutative law. The commutative law is x plus y is equal to y plus x. Then another one law, xy is equal to yx. So this is the commutative law. Then next one, associative law. Associative law is x plus y plus z is equal to x plus y plus z. This is the associative law 1. Then associative law 2. X of y z is equal to xy of z. The next one, distributive law. X of y plus z is equal to xy plus xz. Here x is a common variable. Left hand side, just consider left hand side. X is a common variable. X bracket, that is a multiplication. X multiply y plus z. So right hand side, I am multiplying, then x value I am going to write inside the bracket. So therefore xy plus xz. So this is a distributive law 1. Then another law, x plus yz is equal to x plus y into x plus z. This is the distributive law. Then in digital logic circuit, it's one of the major important questions, important 2-mark question or 4-mark questions is a De Morgan's theorem. Okay, what is a De Morgan's theorem? X plus y the whole bar is equal to x bar dot y bar. This is a De Morgan's theorem 1. In De Morgan's theorem 1, left hand side we will use AND gate and right hand side we will use OR gate. First law, x plus y the whole bar. Here I am giving two variable. The two variable means you can get a input value 0 0 0 1 1 0 1 1. So 0 plus 0, initially I am giving x value 0 and y value 0. 0 plus 0 is equal to 0. 0 bar value 1. So left hand side, first one is 1. Then right hand, going to right hand side, x bar dot y bar, 0 value dot 0 value, then bar. 0 bar, what is 0 bar value? 1. Then y bar value 1. 1 dot 1, answer will be 1. So left hand side and right hand side you can get a same value. This is the De Morgan's theorem 1. So left side is a addition and the right side is a multiplication. X plus y the whole bar is equal to x bar dot y bar. Then second law, De Morgan's theorem second law, xy the whole bar is equal to x bar plus y bar. Here we are using two variables, there are x and y. So